Hey guys, I just wanted to take a minute here and review a few of the things we talked about with triangles and area. So I want to start off with the basic understanding that you guys had already. Last time we talked about area of a rectangle, and we turned around and said the area of a rectangle was simply my length times my width. It doesn't matter what I use for that L and that W. I could use altitude and base, which we've talked about before. We've talked about all kinds of different letter combinations. At the end of the day, we could also call this a height and a base if we wanted to, and then we just say, well, area is simply height times base, or since we're multiplying, the order doesn't matter either. I could do base times height. No matter how it looks, we could find those with anything. So I'm using different letters. Length times width is what they typically use for a rectangle, but I can use any variables. Essentially, one side length times the other side length is really what we're looking at. Well, one of the things that we can kind of look at when we look at that rectangle is we can actually draw a line like that in between the two. See if we can do that a little bit neater. We can do a line in between the two, and if we do a line in between the two, you'll notice that essentially a rectangle is made up of two right-angled triangles. There's one here, there's another one there. Well, if we're looking at that for an area perspective, because again, area is a space inside something, so what we've kind of made all those lines, the area for a triangle looks like it's half the area of a rectangle. So in other words, if I know that this is my height and this is my base again, same idea as that rectangle up top, the only difference is I'm cutting it in half. So I could say the area for a triangle is half of the area, so half, times the base times the height. So we have this mentality of kind of connecting things this way. Now, what we can also do is instead of saying a half of something, you guys usually think of a half as being dividing something in half or dividing it by 2. So instead of using this formula, we could actually change this to saying my base times my height and taking that answer and dividing it by 2. That will represent the area of a triangle. So as long as I have a height, as long as I have a base, you'll notice one key thing, and I'll just circle it here with red. These angles there are 90 degrees. At 90 degrees, we call that a perpendicular, where it meets perpendicularly. So we have the height and the base, where the height meets the base and makes a 90-degree angle. We say that represents the height of my triangle. So if it's a right-angled triangle, well, that's really easy. That's just an edge length. The problem is when I get into triangles that look a little bit differently, and we can make triangles look all kinds of ways, I can make a triangle look like this, which is more typical of a triangle. Well, this one all of a sudden has a height that's a little harder for us to actually see. If I make it bigger here and make this line a little bit better, I can have a line that actually comes down like this. This now would meet at my 90 degree. So now these are no longer a height. My height is actually this dotted line where it's running down. And my base would be the line that perpendicular, this 90-degree mark, is actually sitting at. And again, I have my 90 degree right there. So that means my height's my dotted line and my base is going to be the bottom line. So when I start putting numbers into this, and again, I could draw a triangle just to do one more example, kind of slightly different. I could draw a triangle like this. And again, all sides are different, right? This one, it looks like it's almost all the same. It's not quite a 90 degree here, so we know that this line will actually fall down, and this will make my 90 degree right there, and this would be my height, this would be my base. And I know that because my base is always where the 90 degree mark is. My height is always where that 90 degree mark is. So no matter what kind of triangle I have, whether I have a right angled triangle, whether I have, I'm trying to erase, whether I have a right angled triangle, or whether I have any other version of a triangle, as long as I can create that 90 degree, I can create something that allows me to find that area with this area formula. Going back to that base times height divided by 2. Okay, so same logic as what we did finding for the area for a rectangle. Now, the big reason we want to spend some time with this, so I'll give you an example here actually of just basically finding it. If I give you a triangle, let's do this as an example, and let's say I said this was 4 centimeters, and I'm going to say that this is an equilateral triangle, so both these sides are 5 centimeters, and I'm going to have a line coming down here, and I'm going to tell you that this is, let's say it's 3.5 centimeters. So now I have a couple different measurements. Number one, I know my side lengths are 5. I know my bottom is 4. I know from top to the bottom where that 90-degree mark is 3.5. And the reason I wanted to have multiple numbers in there is I really want you guys to understand when I'm looking at base times height divided by 2, because we know that's my area formula, I want you to understand that in this circumstance, the numbers I have to choose to put in that formula are going to be connected to the 90-degree mark. So that's 3.5 is attached to that 90 degree, and 4 is attached to that 90 degree. The 5 is completely separate from that 90-degree mark. So it's really important to kind of see that and be able to connect that. So knowing that, all your wisdom, we now can turn around and say, to solve this area, we are simply going to say we have a base of 4. We're going to times that by my height of 3.5. We're going to take that and divide it by 2. When I plug that into a calculator, or I go 4 times 3.5, I see 4 times 3.5 is 14. 14 divided by 2 is 7. So we know my area is 7 centimeters squared. So that's kind of how we're going to go through and find the area for a triangle. Now we can move this also into what we've been working on, which is our prisms. And we can actually start solving for triangular prisms. And all a triangular prism, this is horribly written, but triangular prism, all a triangular prism is looking at is it's going to be made up of a few different shapes. It's going to be made up of actually triangles and rectangles. So anytime I draw a triangular prism, let's draw one like this, you guys would know that this is a triangular prism because it has a triangle on both the front and the back. So the triangle here and a triangle on the back, and has rectangles connecting it. If I asked you guys to draw a net, and we've spent lots of time talking about nets, the net for a triangular prism would look something like this. Well, this is a rectangle that's on the very bottom. Then I would have a triangle, if I imagine cutting it, that folded down in the front, and I'd have another one that folded down in the back. The sides would be made up of rectangles as well, and I would end up with something that looks something like that. And I know we did this in class, and you guys did really, really well with it, so you guys knew what you were doing in terms of making those shapes. So now the challenge comes into is simply finding the surface area of a triangular prism by adding all of these different shapes together. You will notice that shapes 4 and 5, the triangles, they're exactly the same. They will always be exactly the same because they have to be on either end. The rectangles can all be different though, and I have to be aware when they are the same and when they are different. They're the same if I make an equilateral triangle. So in other words, all sides of the triangle are the same. Then all my rectangles have to be the same. But if I make a right angle triangle, and I could make a right angle triangle like this, where I have one side here, one side really long, and we learned that that was the hypotenuse, which is my longest side. So we turned around and said, hey, in a right angle triangle, we have to be careful because this could be 3, this could be 4, and this could be 5. And now when this creates its net, the bottom is going to be a rectangle, and it's going to use this, I'll do it in red here, it's going to use this bottom piece and this bottom piece to make this. Now I didn't give a measurement for the length of the prism, but the length of the prism could be something like, I don't know, 7 centimeters. So that means this piece here is going to be 4 centimeters here and 7 centimeters on the side. When I imagine cutting it and folding down that triangle, because that's what we do, we fold down that front triangle, this is going to be 3 and this is going to be 5. So I have all my shapes. Same thing happens here. right angles here, angled here. This is still has to be exactly the same. We said it has to be the exact same. Now again, knowing that that 90-degree mark has to be in that corner. So that means if I'm looking at this, even though it's upside down, I'll highlight it. This here is my, whoopsie, I erased it. This is my height. This is my base. Do my base in a different color. Okay, so I have those two different things. Still have my height and I still have my base. And the reason, again, is it's attached to that 90-degree corner. So we also know, going back here, if I imagine cutting it and folding it, this front side piece right here, that is going to be a rectangle as well. And I'm going to fold it out on that red edge, and it's going to simply go over here, and it's going to be 5 centimeters by 7 centimeters. The back piece, which is going to be right here, built off of here, it's going to fold down, and again, it's going to be a rectangle. Getting kind of messy here. And we know that this measurement is going to be 3 by 5. So you'll notice that each one of these rectangles, rectangle 1, rectangle 2, and I'll circle these, and rectangle 3 are uniquely different. The triangles are exactly the same. So when I'm finding surface area, I have to add all these pieces together. So all I'm doing is I'm finding the area. I would usually start with the triangles because I have 2 of them and it makes it easy. And I know my triangles are base times height divided by 2. That's what we talked about all up here, right? We talked about that when we were looking at triangles. Well, my triangle is base times height. We said my base was 4, and we said my height was 3, and that's all divided by 2. 4 times 3 is 12. 12 divided by 2 is 6. So I have 6 centimeters squared. That's one triangle. You guys told me that I had 2 triangles, or you guys can see that I have 2 shapes, right, where we were doing. We called them 4 and 5 in the other question. So now I have 6, plus I have another 6 because I have 2. So in total, my triangles, I have 12 centimeters squared worth of area. Now I have to do each rectangle separately. So if I look at this, I'm going to look at my number 1 rectangle. My number 1 rectangle, again, we know rectangle is a length times a width, right? My side lengths. So 3 times the length is 7. 3 times 7, the area for that first rectangle is 21 centimeters squared. Now I'm looking at the second rectangle. It's going to make it a little bit smaller because I want to get the other guy in here too. Again, it's a rectangle, length times width. Looking at this one, it's going to be, looking at number 2, it's going to have a length of 4 because, again, I'll highlight it here in red. There's my 4. And again, there's my 7 because we know the separation between the triangles is 7. So I have 4 times 7, and my area, 4 times 7 is 28. So I have 28 centimeters squared. And now I got to try and get my third guy in here, which is going to be a challenge. But I know, it again, it's going to be a rectangle as well. Length times width. Area is going to be, we know that this length was 5 because we know that this side length here, that I'm kind of scribbling dark, is exactly the same. They touch there. So that has to be 5 as well. So this one becomes 5 times 7. 5 times 7 is 35 centimeters squared. Just snuck it in. So now, to find surface area, we said, and I can circle all of these numbers if I want, just to let you know that these guys are actual areas that we found. To find surface area, all we have to do is we need to add together all 5 of the shapes. Well, we have 2 of the shapes in the 12. This has both triangles. So knowing that, I have 12 centimeters squared, plus I have the first rectangle, 21 centimeters squared, plus I have the second one, 28 centimeters squared, and plus I have my third one, which is 35 centimeters, 35 centimeters squared. 35 centimeters squared. So now when I'm looking for surface area, all I'm doing is adding all these pieces together. So it's just simply a matter of addition now. If I have a calculator, it's easy. Otherwise, we got to go 12 plus 20 is going to be 32, plus 1 is 33, plus another 20, 43, 53, 61 with the 8, 61, 91, 96 centimeters squared. So I can say that the surface area for this shape that we did is going to be 96 centimeters squared. So that's how we find the surface area of a triangular prism. Again, doesn't matter, doesn't make a difference. I could have a triangle looking like this, and it's still the exact same approach. If it looks like this, the only difference is I would need to have a height actually given as well. So I could turn around and look at this shape, and I could say, hey, this is going to be 3, this is going to be 4, and let's pretend that these 5 lengths are both 5, right? And this is 10 centimeters. And real quick, if I was to find the surface area of this shape, and I'll do it a little bit quicker this time. Triangles, height is 3, base is 4. I can see that because I know the 90 degrees. So the triangles, I'm simply going to go 3 times 4 divided by 2 because they're triangles equals 6. Again, same as last time. And I'm going to times that by 2 because I have 2 triangles. So I know 12 centimeters squared is the triangles. Rectangle 1 and rectangle 2 on the other side are going to be exactly the same because their side length right here is 5 on both sides, because this one's 5 as well, because it said that they were the same. So I can simply say my rectangles, I can make them easy. I can actually go 5 times 10 equals 50. I have 2 of them because they're exactly the same. So this is 100 centimeters squared. And now I have my bottom rectangle. I'm going to say rectangle for sides just to kind of keep things order. And now I have my rectangle for my bottom. I probably should do that in a different color to make things easier, but rectangle bottom can be done in purple. And the rectangle bottom is going to be made up of this piece and this piece. Those are the edges. So it is 4 times 10, which is 40. And there's only one of them, so I don't need to add them together because now I have my 5 pieces. 2 triangles, 2 rectangles, and 1 other rectangle, 5 pieces. My surface area is simply adding all of these things together now. So 12 plus 100 is 112. 152 centimeters squared. Hopefully this makes sense. I know I went through that last one a little bit fast, but if you need to watch it again, you can figure things out. If you have questions, by all means, talk to me about it and I will help you out. Okay, good luck, guys.